Hey guys, I'm pleased to provide the new content for this series. After presenting in the last three videos the essential points concerning the synchronous communication patterns and challenges, this time the topic will be about the asynchronous communication using messaging. Actually, the purpose of this course is helping you be able to implement different communication styles using the asynchronous messaging, create a specification for APIs relying on asynchronous messaging, choose and use a message broker for your asynchronous communication, and deal with some famous design issues when going asynchronous. To be well positioned in relation to the general microservices challenges and issues, I have to mention that I will present in this course the fundamentals of another communication style, the asynchronous IPC. In addition to that, I will provide some solutions to a particular issue related to asynchronous communication and database transactions. I will start this presentation with an overview of messaging, in which I will describe a messaging architecture independently of messaging technologies. After that, I will show how to implement the different interaction styles with the asynchronous messaging and how to create an API specification when using this pattern. Next, I will compare and contrast brokerless and broker-based architectures and describe the criteria for selecting a message broker. I will then discuss several important topics, including scaling consumers while preserving message ordering, detecting and discarding duplicate messages, and sending and receiving messages as part of a database transaction. So let's begin by looking at how messaging works. A useful model of messaging is defined in the book Enterprise Integration Patterns by Gregor Hope and Bobby Wolf. In this model, messages are exchanged over message channels. A sender, which could be an application or a service, writes a message to a channel, and the receiver, which can be an application or service too, reads messages from a channel. So to have a better understanding of this model, let's look at messages and then look at channels. A message consists of a header and message body. The header is a collection of name-value pairs and metadata that describes the data being sent. In addition to these name-value pairs provided by the message sender, the message header contains name-value pairs such as a unique message ID generated by either the sender or the messaging infrastructure, in addition to an optional return address which specifies the message channel that a reply should be written to. The message body is the data being sent in either text or binary format. There are several different kinds of messages. The first kind is document, which is a generic message that contains only data that the receiver decides how to interpret it. For instance, the reply to a command is an example of a document message. The second kind is commands. A command is a message that is the equivalent of an RPC request. It specifies the operation to invoke and its parameters. The third and last kind is events. An event is a message indicating that something notable has occurred in the sender. An event is often a domain event, which represents a state change of a domain object such as an order or a customer. To notice that the microservice architecture world, the most used kinds of messages are commands and events. Messages are exchanged over channels. The business logic in the sender invokes a sending port interface, which encapsulates the underlying communication mechanism. The sending port is implemented by a message sender adapter class, which sends a message to a receiver via a message channel. A message channel is an abstraction of the messaging infrastructure. A message handler adapter class in the receiver is invoked to handle the message. It invokes a receiving port interface implemented by the consumer's business logic. Any number of senders can send messages to a channel, and similarly, any number of receivers can receive messages from a channel. There are two kinds of channels, point-to-point and publish-subscribe. A point-to-point channel delivers a message to exactly one of the consumers that is reading from the channel. Services use point-to-point channels for the one-to-one interaction style. For example, a command message is often sent over a point-to-point channel. A publish-subscribe channel delivers each message to all of the attached consumers. Services use publish-subscribe channels for the one-to-many interaction styles. For example, an event message is usually sent over a publish-subscribe channel.